Today we will be using experimental probability to determine whether an event is likely to occur or not. And so what experimental probability is the number of times a certain event happened on top of the fraction over the total number of trials on the bottom. So questions number 1 and 2 ask us to find the experimental probability. However, we're going to write it in 3 different forms. In the fraction form, which is what we're going to end up finding first, and then we can write it in either the percent or decimal form second, and then one of them in third. So Luke is practicing for his tennis serve, and he gets 21 out of 27 serves in. What is the experimental probability that he will get to the next serve in? So they want to know the serve in. So they want to know the probability of the serve being in, serve in. So let's take a look at what a success is. The successes are how many serves he gets in. So it says if he gets 21 out of 27 serves in, that means he got 21 successes. He was successful 21 times. That is the number of times the certain event happened. The certain event was the serve being in bounds. Out of 27. Out of 27 tells me that that is the total. So what we want to do from this point, since we've got the fraction, is just reduce it. Take out the common factor. So I see 3 goes into these numbers, and so I'm left with 7/9. So that's one of the answers, but I still need to find out what the decimal form and then the percent form is as well. So if you don't know the rules with 9, then you just have to do the top dog in the doghouse. So 9 into 7. So it doesn't go into 7, so you add the decimal and the 0, and you'll see that it ends up going in there 7 times, which makes 63. But we get the same number. And so whenever you have the same number there, we have a 7 again, you're just going to get that 7 repeating. So the answer for the decimal form would be 0.7, or actually I'll write that 0, 0.7 repeating. Well, the decimal form is 0.7, so I'll write a few 7s out there for you, and those 7s are repeating. Well, the percent form means that we're just going to move that decimal, multiply this by 100, which moves the decimal 2 spaces to the right. So it ends up becoming 77.7 repeating percent. So there's the answer for number 1. That repeating bar would go over the 7. Next problem is Jose saw 50 people. Okay, so he saw 50 people. That might be important. Let's read on. 14 of them were wearing red shirts. So we'll say 14 reds. That might be important. And 17 were wearing blues. So 17 blues. So let's continue. It says, what was the experimental probability for the next person he sees to be wearing a blue shirt? Okay, so we don't care about this number. This is not important. We want to know this. And typically we might need this number if we needed the total number, but they give us that. See, there must have been more than just red and blue shirts, because the total people, this was our total here, the total was 50. So we're going to write down the probability of seeing a person in a blue shirt. So P, and then the event goes inside the parentheses. The event is the blue shirt. Would be 17 successes over 50 number of trials. So 50 was the total number of trials we have here. And so from there, we've got the fraction form. It doesn't reduce, so we'll just leave it like that. Now this time, instead of finding the decimal first, I'm going to find the percent. It's easier. See, if I just multiply this by 2 over 2, I get 34 over 100. And 34 hundredths, well, that's the percent form right there, 34%. The decimal form, just move the decimal 2 spaces to the left, and you'd have it, 30.34, so 34 hundredths. Well, the next set of directions just says solve, so we don't need to find the fraction, decimal, and percent. I'm just going to find the fraction form here for these problems. And it says, during the exit survey after a play, 75 of the first 120 people surveyed said they did not like the play. Okay, so let's write that down. So the probability of not liking, let's just say that, not like. To not like the play was the successes was 75 out of the total number was 120. So that was not liking the play. So we're going to end up needing that, and we might need how many like the play. Because whenever they have the word not, typically they're going to have the opposite of that as well. And so what is the experimental probability that the next person surveyed says he likes the play? So liked this time. So if the total number was 120, 75 people did not like the play. We have a total of 120. So how many people liked the play? Well, all we have to do is subtract those two numbers. So if I do 120 minus 75, that would give me the number that liked the play. Well, let's see here. That would be 20, and then plus 25 would end up giving me 45. So 45 people ended up liking the play. So let's write that down. 45 out of 120. And so from this point, what we need to do is reduce these fractions to figure out what that is, because there is a common factor. So if you don't see the big number, let's start with 5. Let's take out a 5, divide them both by 5 there. And we end up with 9. And down below, 5 goes into 12. We have 2 times. 5 goes into, see, 12 minus 10 makes 2, so 20. It goes in there 4 times, so 9 over 24, but there's still more common factors. So reduce further. You want to reduce down to the simplest form. So we got to take out another 3. And so when we do that, I see that 9 goes into 3 times. So it makes 3, and then 24 divided by 3 makes 8. So there it is. 3/8 of the people liked the play. So if they ask you the number, or tell you the number that did not like, the people that liked, you just subtract the total, or the amount that did not like, from the total, and that gives you the people that liked the play. What is the experimental probability that the next person surveys will say he or she did not like the play? Well, we actually already found that. 75 over 120, but we'd have to reduce this, and we've got the reduced form already for the ones that like the play. So all you have to do is do the subtraction again. Use that little method I showed you over here. See if you subtract. So people that liked, we said, was 3 out of 8. So this is the number of people that liked the play right here. This is the total in just the reduced form. It's an equivalent fraction to the one up top. It's just in a reduced form. And so this will give us a reduced form already without having to reduce this fraction. So all I have to do is take the total and minus the people that liked the play, and it gives me the people that did not like the play. So 5 did not liked. And so that means it's 5 out of 8. So 5 out of the total. And that would be the reduced fraction. Or you could just use the 75 over 120 and reduce that fraction. Well, those are the first 3 problems that you'll see on tonight's homework. Let's take a look at the other ones in part 2.